In this video, I'm going to show you how you can import everything into your AI agents. This includes over 95 different types of file formats, covering documents, presentations, spreadsheets, images, and audio. You can then build hugely powerful agents that interact with all of that data. I'll show you how to use solutions like LlamaParse and Docling to extract information from all of those files. LlamaParse is quick and really easy to get set up, and it has extensive file compatibility, whereas Docling is open source, self-hostable, and it also uses no external APIs, so it can be extremely cost-effective to use, and it's also great if you or your client have strict data security or privacy requirements. These solutions use advanced features like OCR, native parsing, and AI to effectively parse and extract the information. And the results from these are often a lot better than what we would get out of the box from n8n. For example, in the extract from PDF node in n8n, this just takes any of the machine readable text from the PDF and outputs it as the text. So you can lose a huge amount of the context of the document, for example, images, layout, formatting, tables, and more. At a high level, let's say your RAG ingestion workflow is listening out for new files within a Google Drive folder. You could upload any of these types of files or any of the other file formats within this spreadsheet. The n8n workflow will pick those up, it'll download the file, and then send the file to one of the services that we've talked about previously. So either of those services will be able to use their OCR and internal AI models to extract the information in a structured Markdown format. And that's key. When we get this consistent Markdown format, then it's really easy to ingest this into our overall vector database. And from there, it's just like our standard RAG workflows that we've gone through in multiple videos and in our RAG masterclass. You just take that Markdown, we break those up into chunks, we use an embedding model to create vectors, and those vectors are stored in a vector database. From there, you can ask your agent a question, that goes to the agent, it will query the vector database to get semantically relevant results for that query, respond to the LLM, and then the agent will decide how to respond like it does here. It's widely cited that between 80 to 90% of data in an organization is unstructured, and that can be spread across emails, documents, transcripts, image files, audio files, and lots more. And being able to ingest and parse all of these kind of files into a consistent Markdown format offers a massive opportunity for us to be able to use this untapped data. Through these workflows, we'll even be able to ingest data from spreadsheets. Now, if you have data from spreadsheets in an unstructured fashion, then it could be a really good solution for this. Otherwise, if you're holding structured data such as transactions, financial data, analytics, and more, then you can use an alternative method, which is NLQ, and I go through a separate approach for how to ingest and query that data in a video linked in the description. Finally, we have Mistral OCR, which we've covered more than once on this channel. It only supports PDF file types, but it is very fast, pretty high quality, and quite affordable, and also very easy to integrate with. This is still a service I recommend, so we will be touching on that later on. By the way, all the workflows shared in this video will be shared with our community, so if you want to get a head start, then check out the link in the description. Also, I put a lot of work into researching this video, so I'd really appreciate it if you give it a like and subscribe to this channel. Let's get started with setting up LlamaParse. They offer a fairly generous free tier, so you can just go to llamaindex.ai, go to document parsing, and then click get started. From there, just go through the sign up process, and pretty quickly you should get access to your cloud console. When you do that, you can go to parse on the left hand side, and here you'll see an online playground type interface where you can drag and drop in your files and then tweak the settings and then test the results. From there, once you're kind of happy with the overall results, then you can get the code snippet, and then we can integrate this with n8n. To explain LlamaParse's pricing, it costs $1 for 1,000 credits. You'll see each of the operations here consumes a different number of credits, which could be a bit confusing. So if you go to their billion, you see that on the free tier, you have 10,000 credits available per month. And if you look at the different modes of operation here, you'll see that the agentic mode, which works well for most types of documents, costs 10 credit per page. So roughly you'll get about 1,000 pages of usage per month on the free plan. When you're processing PDFs in particular, I'd recommend using at least this agentic mode, because the cost-effective mode is mostly for text-heavy documents, and a lot of the times PDFs are going to be a bit more complex than that. You can tweak the LlamaParse settings quite a lot here. If you go to advanced settings, you can choose the document model to use, you can use what type of parsing mode. So let's keep things simple. I'm going to select agentic here, and I'm going to drop in this PDF. So I'm just going to upload that and drop it in from my computer over here. And from there, I can just select parse and then wait for that to be processed. So now on the right-hand side, we see we have a Markdown result. So this is a nicely formatted result. You can also get a text, JSON response, and lots more. But let's just quickly compare the Markdown response we get from here to the original PDF. In terms of parsing this document, it's done a really good job of it and also has preserved formatting very nicely. In this case, it's taken the images and it has annotated a general description of those images, which is quite nice. So if you do not want to go the multimodal RAG route where you're going to serve the images directly to the user, then it's quite a nice function to just have general context of those images directly in line here. Okay, that's looking good. Let's go into n8n and try and get the same result via their API. I have a new workflow here. I'm going to click on this add first step and I'm going to select trigger manually just for the moment. Next up, I'm going to type HTTP, and here I want to get a PDF that we can use for testing to test the LlamaCloud API. So in this case, I've just uploaded a PDF to a Supabase public bucket, but you can use any PDF really from anywhere, or you can ingest the data from Google Drive or whatever you want. So now within HTTP, I have a method of get, and we can just use any publicly accessible PDF for this. And I'm going to click execute step. We now see we have a binary response of that PDF file that we can now pass in to LlamaCloud. Now, next up, we want to integrate with LlamaCloud directly. So we're going to add in another HTTP node here because there's no built-in node for LlamaCloud, unfortunately, with n8n. And in this case, we need to go and get an API key. So we click generate new API key. You can name that whatever you want and select create secret key, then copy out that secret key. Now to integrate with LlamaCloud, I've gone to their API reference to see what endpoints we need to hit. And we have this upload file endpoint. So let's start with that and go to curl on the right hand side, and you can copy this out and just select the copy button. Now within here, I'm going to select import curl and select import. Okay, we have some initial fields populated from here. Within authorization, we don't want to just have this as plain text here. So we'll add this as a credential instead. So we'll go to authentication and select generic credential type. Then under header auth, go down to create new credential. At the very top, just make sure to name that so you can use it again. And then for name, the header for this is just authorization. So let's name it that. And then after that, we need bearer space API key. So within the value there, I've selected expression, type bearer, and then I'm going to just paste in this API key, press save. And now that should be our credential that we can use for any connections to LlamaCloud. From here, we should remove this authorization piece here because that is only for plain text. It's no longer required because this credential is going to inject that into the request. And now on the right-hand side, we see there's a lot of extra items we can add to the request. The first and most important thing is that we need to add a file. So let's go back into this and we're going to select n8n binary file. We're going to name this file, and then the input data field name, we just type data, and that's how n8n maps the binary data to this field. Then on the right-hand side, you'll see there's just so many different options. So LlamaParse is very configurable as to how you want to OCR and parse your documents. Instead of just guessing what to do here, I'm going to go to LlamaCloud, and within the code snippet, you'll see we previously selected agentic mode, and this was the mode that we used to upload our PDF and then get a pretty good result. So I'm going to select this code snippet, and if you select Python, JavaScript using API calls, you can see we have the form data that we need to pass to LlamaParse to get the same kind of result as that. So we can just copy and paste this in to the fields within n8n. So I'm going to select add parameter, model, and OpenAI GPT-4 1 mini, and that's the model. So you can see in this case, it is using OpenAI's vision capabilities to OCR the documents, but it's doing more behind the scenes than just that. So we're going to select high-res OCR and set that as true. That's selected as true. We're going to add in another parameter and then go back. Adaptive long table is true. Just type in true for that as well. Add another parameter. Outline table extraction, also selected true. And finally, we can get it to output tables as HTML. It's questionable whether you should do this or not. HTML has some added flexibility around tables, like using merged cells, for example. So you can set that as true for the moment here. And from that, we should have everything we need in order to upload this document and then wait for a result for retrieval. So now I'm just going to save that. From here, I'm going to execute this workflow and then check the response that we get from Llama. Okay, I've just run this request and now we've got this response from LlamaCloud. We have ID and status of pending. And that means we're not getting the response back from this initial request. It happens asynchronously. There's two ways we can get a response from this. Either we can do it in this fashion and just keep polling LlamaCloud until the status is ready. Otherwise, we can set a webhook URL in the request form data body to LlamaCloud. And then when it's finished processing that file, it will hit the webhook URL, and then we can then process that separately in n8n. For the moment, I'm going to use a simple polling mechanism here to check the request and then poll every few seconds. When we get a successful result, then we can then get the parsed content. So let's go down to the documentation again here. If I search for pending, which is the response we got first time around here, we see that this is going to respond with multiple different values. So we have pending, success, error, partial status. So I'm going to start with handling the pending case. In this case, I'm going to select a switch node over here. First off here, we're going to drag in the status column here, and we're going to handle the case of where that status is pending. If it's pending, we want to poll the result again to see what the response is. So what we can do here is, before we do this, just add a wait node, a wait before execution. So we're going to wait at least, let's say, 10 seconds before we even attempt to poll, because it's going to take some time to process the document to start with. And then within this switch, we can rename this output to pending as well. That will show up within this label here, which is pretty handy. What are the other statuses we need to handle here? So it's not just pending, obviously. It's going to respond with a bunch of other potential options. We have pending, success, error, and partial status. So let's handle the pending and success statuses for the moment here. And then if it responds with anything else, the workflow will just not continue. I'll go into this switch. I'll select add routing rule. And again, I'm going to copy in this JSON status, and we're going to handle the case where this equals success. I'm going to reorder these over here as well. So success is at the very top. I'm going to rename the output to success, and then these will show up in the labels here. So if it's marked as pending, what we can do is add in another wait node after that. So we're going to wait, let's say 3 seconds between each reattempt. And then we want to poll that service for a response. To poll the service here, we're going to use a HTTP request. So to get the status of the job, we're going to use this get parsing job details endpoint. So we're going to copy this out and then go to URL. And then within the expression here, we want to map in the job ID from the previous request. I don't see the input data on the left. So just to be quick, I'm going to execute this workflow again. And then I should see that on the left-hand side, and then I can map it from there. Okay, it showed up authorization failed, which is as expected. For authentication, we want to select generic credential type and select header auth, and then go down and we want to select the LlamaCloud key we added earlier. Now we want to change this from fixed to expression, and I'm going to click on this button to expand. We want to replace this job ID with the ID we got back earlier on from the first request. So I'm going to remove these parts. And the right-hand side here, we have a long response, which is good. So we're now going to go back and merge this into the very start. And from there, and if the response from that is success, then it should from there route to the successful part of the flow. So I'm going to rename this get parsing job details, and this will route back to this initial switch. So we're nearly there. We now have the job details, so we know when the job is successful. From there, we need to send a final request to LlamaCloud to get the Markdown result from the parsing. If you go through the documentation, there's a bunch of different options here. We're going to get the raw Markdown result. For this, I'm going to copy out this URL, add in another HTTP request. Finally, for methods for this is going to be get. And here we want to pass in the document ID. So I'm going to select expression again, and I'm going to replace this job ID placeholder in the URL with the ID that was passed into the switch node. And here we should then get the results from that. So I'm going to click execute step from there. Within this HTTP request, I'll select authentication, again, generic credential type, header auth, and then I'll finally select this LlamaCloud account. Now I could use pinned data from the previous execution for this, but just to keep things simple, I'm going to select execute workflow and let this run through again. Now while it's doing that, it's waiting 10 seconds before going through this initial switch router here. Now we've got the parsing job details and we get the document Markdown, which is great. Depending on the general size of your documents, you may want to increase or decrease your wait times, but in this case, it was pretty much perfect. The response data we're getting back is looking good from here. And finally, we can now just load this into a vector database. From here, we have document Markdown. I'm going to select Supabase, vector store, and then add documents to a vector store. If you want to learn more about the process for ingesting documents to a vector store, I'd highly recommend that you check out the link in the description to our RAG masterclass video that we have on our channel, where Daniel goes through this in a lot of detail. But just to go through this very quickly, we're going to select an embedding model here. So I'm going to select text embedding 3 small. And finally, we're going to select the table that we want within Supabase. So I've previously set up this documents table in Supabase. That's currently empty in Supabase, and that this will then populate the embeddings from that document. Now for document, we're going to select a default data loader, and I'm going to select a recursive character text splitter. which is good, and then select split as Markdown. I have an entire separate video on why that's a really useful flag to set. Within this default data loader, we're loading all of the input data, so we're going to load this data in, and from there, we should be good to go. So seeing as we got a good result previously, I'm going to select all of this and select P. That's going to pin that previously successful data, so we do not need to actually process this document again. We have the response from here, and then we can then test the subsequent nodes in the workflow. And that's a super feature of N8N. So I'm going to select execute workflow here, and it's gone through using the previous test data, and now it will have loaded that data to Supabase. So let's have a look at that. And there you go. We have the data directly in the vector database, and then we can chat to that data directly by creating a new AI agent. Within this workflow, I've just created a very simple AI agent. I have a when chat message receive node, which is going into an AI agent. Here I've selected an OpenAI chat model. You can use whatever model you want. Simple memory just for testing. I've hooked in a Supabase vector store here, which is going to do a semantic search based on whatever we have within this Supabase table here. The test data we use with LlamaParse was this PDF file here. So I'm just going to ask a simple question like how to connect the drain line. So I'm now asking that question, and it should go to the Supabase vector store and then retrieve a response. The response is looking good for that. In this case, it queried the vector store. It retrieved a bunch of chunks based on the data that was uploaded during the ingestion process here. And then the AI agent interpreted that data and then responded to the user based on the query. But I'm going to test quickly here with a Microsoft Word docx format. So we have a sample document here, which includes some formatting, tables, and a bunch more. So I'm going to save that. I've also just uploaded this docx file to a Supabase storage bucket just for some initial testing here. But I will be explaining how to build this into a bigger, more fully fledged RAG ingestion pipeline, such as where it's been picked up by files within a Google Drive and then handling updates and lots more. But let's just keep things simple for the moment. We're just going to keep ingesting this file, and I'll unpin this data. So within this HTTP request, I've now provided the docx file instead. And within this wait, I'm going to reduce this a little bit down to maybe 7 seconds, because when it goes through this process, it's already going to wait the first time around as well. So I've now selected execute workflow, and it's now uploading the document. I got an error back, which is to say the requested resource cannot be found. I realized I was initially hitting the get parsing job details at the very end, and whereas I should be hitting the get job endpoint instead, which gets the response status. So from there, I'm just going to go back and remove the / details from the end here, and then re-execute the workflow, and it should work from here. Okay, that worked, looking good. The document Markdown on the right-hand side is looking good as well here. It has extracted the tables directly from this docx file as well, which is really useful. The files I use for demonstrating here have been pretty small, and you could keep the wait times very short in cases like this. Before I demonstrate the next solution, I'd like to just explain how I've built this LlamaParse workflow into our RAG ingestion. So as LlamaParse is very versatile in handling lots of different file formats, it's a very useful extra feature to add to your overall RAG pipeline. And that's what I've added in this case. This is an extension of the RAG pipelines that Daniel went through in our RAG masterclass. In this case, it's ingesting files from a Google Doc, and it's going through the process. Here we're handling the files differently based on their MIME type. So we're handling Google Docs, PDFs, HTML, and so forth. But we have an other doc types route here. So within this switch, I have this extra code I've added in here, which checks to see if the MIME type of the incoming file matches any of these. In this case, I'm matching against lots of the different document MIME types that LlamaParse supports. And we're handling CSV, Excel, and Google Sheets quite differently and storing those within a relational database. Again, we have a separate video on that if you want to learn more about that in more detail. But then if it matches the MIME types that we're targeting for LlamaParse, from there the flow is very similar to the previous one that I demonstrated, where we're uploading the file to LlamaParse, we're waiting, we're getting the processing status, and we're checking to see if the job is ready. When it is, we're parsing that document, we get the response, then it goes through the rest of our RAG pipeline, which can correctly handle creates and updates and deletes so that your data is not being duplicated or out of date. We're doing some other features like metadata enrichment and contextual embeddings, which are more advanced RAG features which can improve the response quality. So the end result of this is that LlamaParse now has enabled us to slot in an additional 90 plus extra file types that we can then ingest into our RAG agent. If you want to get your hands on this system as well as instructions and lots of other setup materials and courses, then check out the link in the description to our community. Next up, I'm going to explain how to set up and use Docling, which is a very powerful document parsing and OCR framework. Docling is an open source project by IBM, and it's where you can parse multiple document formats: PDF, docx, PPTX, XLSX, and more. It's able to parse files natively, and then it uses OCR under the hood where it's required. Docling has some great features, the main one being that it does not use external APIs. Because Docling is self-hostable, you could upload vast amounts of data without having to pay the API costs of the likes of LlamaParse or Mistral OCR. You're just paying the actual server costs to run Docling. Docling is fantastic for both cost saving as well as data security and privacy, but there are some drawbacks to Docling. It tends to be slower to process than other services like LlamaParse, for example. And as it's a Python library, you need to deploy that and then make it available via an API that we can hit via init. I'm going to show you a method that you can do this to quickly get set up and test Docling for your use case using render.com. When you deploy Docling, you should make it available via the API, but it's also very handy to have a UI that you can quickly test and upload documents and test the responses. The easiest way I found to use Docling is to use this Docling serve GitHub repository because it allows us to run Docling as an API service. Otherwise, you just have Docling as a Python library and need to do a lot of setting up to make this available. I already have Docling set up here. I'm going to set up a separate instance to explain this. Just to quickly explain my setup for this, I have the Docling serve main container from the GitHub repository set as a private container. Then I've created a separate, very small app with the help of ChatGPT, which is a Docling serve gateway, which password protects the UI, and then it also enforces an API key requirement if you're hitting the endpoints. If you're using render, that's one of the correct ways of doing this without you having to make your Docling instance publicly accessible, which clearly has its security risks. I'm initially not going to follow this pattern because it's going to overcomplicate it for demonstration purposes and the video, but I will be explaining afterwards how to separately set up this public access gateway, which then enforces these passwords on the main Docling instance. So I've already got Docling set up, but I'm going to create a new one to start with, and I'm going to create a new project. For the initial demonstration here, I'll just be creating this as a publicly accessible service. Later on, you will need to create it separately as a private service if you want to password protect everything. But just to start with, I'll select new web service here. Then I'll go to existing image. And then within this GitHub repo, there is an existing image that we can use to really simplify the import of this, which is great. So this is the image URL, Docling serve CPU latest, and I'm going to select connect. As for the packages to use, I found that you need to use at least the standard package on render in order to even import this app. Unfortunately, Docling is quite resource intensive to use. Because it's not interacting with other API endpoints, it's doing its own processing, so you will require more resources. Just for testing this, you can use a standard, but remember, on render, you're only billed for the amount of time that you have the app deployed. Then you can just have this app deployed for a few hours or a day or two, and then turn it off later if you want. And then you're only billed for that small amount of the monthly fee. And then as an environment variable, I want to enable the UI element that you see up here. So I'm just adding in the environment variable Docling serve enable UI. Then the value of that is 1. And then from there, we should be good to go. Just press deploy web service and then wait for that to be deployed. Then you'll see the deployment progress for it here. If you're planning to deploy Docling in production, it's probably going to end up being quite expensive if you're using render.com because plans start to get quite pricey the more RAM and CPU is required. But render.com is a very useful service for you to quickly spin up apps so you can either test them or evaluate them in your systems, or for any services that have pretty modest resource requirements. Okay, excellent. It took about 5 minutes to set up and deploy, but it did it all by itself from there. And now if I just go to this URL, I'll go to the next page. I see not found. Whereas if I type /UI at the very end, we now see the Docling serve UI, which is great. Now we can test out converting a file. So I've pressed upload file and I've selected the file that I uploaded previously to LlamaParse. I'm going to select a few options here quickly. I'm going to enable and force OCR. I'm going to select this Tesseract OCR engine, OCR language of English. I'm not going to export images, so it will only show up as placeholders within the Markdown. I'll get it to respond in JSON and Markdown as well. Okay, from there, I'm going to press process file. Now we're going to wait for that to process. We can see at the very bottom right how long it's taking to process those. Okay, so it has processed. It ended up taking about 45 seconds to process that PDF. So the response here we got is the Docling JSON, we have Markdown, and we also have this Markdown rendered, which is a nice way for you to quickly just test the results without having to bring it through init. The overall result from this is quite good and, in my opinion, is usable. Based on the settings we use in either of the approaches, I think LlamaParse's results are better in this test, but at the same time, these results are very usable. So That's looking quite good. A few things to keep in mind. You could run out of memory when using Docling, even on a $25 a month render instance. This easy OCR seemed to be a culprit for me, whereas I expected it to be less memory intensive, but that was causing the server to crash. So those are a few things to keep in mind. So you may need to tweak your settings on Docling, both for server performance as well as the actual performance of the output. Now let's integrate this with N8N. Because we've deployed Docling Serve to a server, it's exposing an API endpoint that we can hit via N8N. If you look at the Docling Serve documentation on GitHub, you see the usage of the API endpoint, and the endpoint is v1 convert source. So how you access this is that you get the root URL of your web service, and then within N8N, you create a HTTP request, and then add that as your root URL. Then just add the v1 convert source to the end of it. This page provides more information from there. From there, you need to hit this URL, make the method as post. Then you want to construct a JSON request following the instructions of this. So you can get ChatGPT to do this, or you can follow the examples that you see here. So you can select the options and then provide the HTTP source that you want it to pull data from. So from here, I provided these options. These options are pretty similar to what I tested when I was using the web UI for this. And then for sources, I'm providing the URL. So the Docling instance is going to take that PDF from the external server. It's going to download it and then process it, parse it, OCR it, and then give us the Markdown response directly to the N8N instance. In this case, I'm using this test PDF again, and this is uploaded to a Supabase storage bucket. But of course, instead of hard coding a value here, you can map in a value that you can use during your ingestion workflow. I've pressed execute step here, and it should take around the same time as it took to process this via the UI. That took 42 seconds to process, and then we have this Markdown content that we can map into the next stages in our RAG workflows. Now that we have the Markdown, the easy part from there is to store that into a vector database, and we can use the exact same process we went through earlier on. So we can just map that to the Supabase vector store, and then just make sure we're mapping the Markdown content to vector store. Again, Docling is quite resource intensive. When I was initially deploying this, it did not work in the initial lower tier, so I needed to update the instance type. But depending on your resource usage, you may need to scale this plan up even more, or else deploy it to another service or host as a more permanent solution. So as mentioned previously, I've set this up as a public instance, and you can then hit this UI without password protection. But in production, you're going to want to hide that UI behind some sort of password screen at least, and you're going to want at least an API key requirement whenever you're hitting the API endpoints. How I've done this is that I've set up the Docling Serve app exactly as I did previously, apart from that it's a private service instead of a web service. Then I have a separate service set up, which is a public app, and then this feeds through the requests through to the main Docling Serve app. I did a bit of back and forth with ChatGPT to get this gateway set up. What I ended up doing was I set up a private GitHub repo, and in there it created a Docker file, as well as an entry point and an Nginx configuration. And from there, information is stored as environment variables, such as an API key and the username and password for the UI. And so I uploaded these files to a private GitHub repo, and then went into render and created a new web service. From there, I connected my GitHub account, and then that was able to access the private repos. So I selected this Docling Serve gateway. As this is run as a separate instance, again, it's built separately, but you can use a starter instance for this, and all the other settings for this can be the same. And then for the environment variables, you provide whatever API key you want to use, as well as a password. Then you need to provide the private URL of the upstream app. So the upstream app in this case is the private Docling web app. The end result of that is a public gateway app, then a private Docling Serve app. Then if you try to access the UI portion of this gateway app, then you're hit with at least a basic username and password auth screen. And when I sign into that, then I have full access to this Docling Serve UI. And then instead of hitting the main app as I did previously, then we're going to hit the actual gateway app itself. This will relay on the request to the private app. Then for authentication, you're going to select generic credential type, header auth, and then you're going to create a new credential. It should be authorization. And then you need to add in the authorization. In this case, the name is X API key. And then the API key itself is whatever you entered in as an environment variable for API key when you were creating the gateway app. If you want to get access to all of this code that you can quickly spin up this Docling Serve gateway app, then I'll be sharing that within our community, links below. The last option I'd like to touch on is Mistral OCR, which I went through in our multimodal RAG video. Mistral OCR only supports PDFs, but if you're mostly just concerned with those, then it's a really good option. It's very, very fast to process these. It's pretty high quality. It's very easy to use, and their cost is pretty decent. It's $1 per 1,000 pages if using OCR, and their annotations feature costs $3 per 1,000 pages. This is the feature where it can use OCR to read and extract information about images and diagrams and things like that within your documents, and then export those in a JSON format. While LlamaParse offers a 10,000 credit free tier at the moment, if you're looking to really go at scale and don't want to deploy your own solution, then Mistral OCR is still a really good option and tends to work out as a lot cheaper than using LlamaParse. If you want to understand how to get set up with Mistral OCR, then make sure to check out that multimodal RAG video on our channel where I go through two separate workflows. One is a simpler workflow where you can just ingest a PDF, upload it to Mistral, and then retrieve the Markdown result from that and upload that to a vector store. I also show you a more sophisticated workflow where Mistral OCR not only responds with the overall Markdown, but it will also respond with the extracted images in a binary format. So we can then split out and upload all of those to a Supabase bucket. And from there, those are made available to the AI agent. So when the user asks a question, we can actually serve those images back to the user. If you want to learn more about how to use Mistral OCR, then check out the link in the description. Mistral's OCR is pretty easy to get set up, and the request bodies are usually pretty straightforward. LlamaParse just has a very large amount of options that you can work through, different document models, different parse modes. But if you want a pretty simple solution and one where you can implement this kind of multimodal RAG flow very easily, then Mistral OCR is a good option for that. All of the templates and code shared within this video will be shared with our community, so make sure to check out the link in the description for that. And don't forget to like this video and subscribe to our channel for more deep AI content like this.